when they're back. Okay, we're doing 5-7. We're skipping all the way to 5-7 because I want to. And we're adding, subtracting, multiplying matrices today, all the things. So we're talking about matrices that are the same. Matrices are only the same. Two matrices are equal if they have the same dimensions and corresponding elements position by position. So even though these numbers are all the same as these numbers, they are not in the same position, so they are not equal matrices. Now, this is a 2x2 matrix, and this is a 2x2 matrix, right? Okay? When you are naming the size of matrices, you go row by column. So this has 2 rows, and it has 2 columns, okay? We're going to get used to doing that here in just a second. So 2x2 rows by columns, okay? All right, so in part A, they're saying what does P and Q have to be and what does X and Y have to be in order for those two matrices to be the same. This kind of seems like a little silly, but whatever, okay? This is a 2x2 and this is a 2x2 as well, right? Okay, so we know that they can maybe match up, but in order for them to match up, like what would P have to be? -1. P would have to be -1. What would Q have to be? 0. What would X have to be? 2. What would Y have to be? 1. Yeah, that's it. That's all. Not too bad. Okay, B. What the heck? What size of matrix is the XY guy? 2x1. He is a 2-row, 1 column. Not a 1x2, he's a 2x1, right? What is this guy? 3x1. 3x1. How does that work? I don't know. If possible. No. Not possible. You cannot have a 2x1 matrix be equal to a 3x1 matrix. Not going to work. Oh. So I cannot assign an X and a Y in order for that to be true. Got it? Not too bad. That was kind of silly. Okay, now we're adding. You can only add. Only add and subtract same sizes. Okay, you can only add and subtract them if they're the same size. So in A, they're asking us to add because there's a plus sign in between them, right? Can I add those two together? Yeah. Yes, they are both 2x2s, right? 2x2, okay? And all you do is you add this one cell for one cell. So I'm literally adding 5 plus a -4. 6 plus a negative, or 6 plus 6 is, I did not say that right. -6 plus 6 is 0. There you go. 8 plus 8, 16 goes in that bottom left, and 9 plus -3 is 6. There you go. Good? Crazy. Okay, B. I got this guy going on. Can I add those two together? Yeah, what size is he? He is a 3x1, right? Each one of those is a 3x1. We're adding them, and I'm going to end up with another 3x1. Okay, 2 plus -6, -4, 5 plus 3, 8, 8 plus 12, 20. 20? Yeah, there you go. There's that matrix, okay? You can't do C. How's come? Yeah, A is a 2x2. B is a what by what? 2x3. 2 rows, 3 columns. Yep, 2x3. So 2x2, 2x3 cannot add them together because they are not the same size. Got it? Not too bad, not too bad.
So this way is rows.
Mm-hmm, mm-hmm. Rows first by columns. Yep. Yep. Okay, good. Go to example 3. Now we're to subtracting. Okay. Can you do part A? Yes. It's just going to be a 2x2 again, right? Okay. All right, but be careful. You are doing -5 minus -3. So it'll be -5 plus 3, which is -2. Yep. Okay. Next, we've got 6 minus 2. 4. Yep. Okay. We've got 2 minus 5. -3. Yep. And then we've got 4 minus -8. So 4 plus 8, which is 12. Yep. That's what he ends up being. Okay. Go a little bit slower on the minuses because he's kind of crazy. Okay, B, can we do B?
Yeah.
Yep, he will end up being a what? By what? He'll be a 1 by 3. 1 by 3 and 1 by 3 gives me a 1 by 3. Okay, 8 minus 3. 5. Okay, 6 minus 5. 1. Negative 4 minus a negative 8. So negative 4 plus 8. 4. 4. Okay, 5, 1, 4. All right, what about C? Cannot. 2 by 2 and 2 by 1 doesn't work. Okay? All right, the next one is a scalar multiplication. So you're just multiplying everything by 5. Yep. These, it doesn't matter what size they are, you're just taking that 5 and distributing them through. So 10, negative 15, 0, 20. You got it. Okay, this is multiplying by 3/4. Yeah, so everything gets multiplied through by 3/4. I don't know if you can see that bar there. 3/4. What is 3/4 of 20? You don't multiply the bottom. It'd be 60 over 4. What's 60 divided by 4? 15. Right? 3/4 of 20 would be 15. 3/4 of 36. By the way, 3/4 times 36. This would be like 36 over 1, right? You could cancel. The 4 becomes a 1. The 6 becomes a 9, right? Or 36 becomes a 9. So 3 times 9 is 27.
I did it at dumb way.
What did you do?
Half of 27 plus half of the half.
Half of the half.
18
Yeah.
plus 9.
That's fine.
I-
Totally. That's
fast,
totally
I
fine.
guess.
Yep. So 3/4 of 12. 3/4 times 12 over 1, right? If I'm doing that guy. 4 and 12 can cancel, be 1 and 3, so that is 9. 16, 3/4 of 16, negative 16. 16 over 1. The 4 can become a 1. The 16 become negative 4, so that is negative 12. Thank you. My card is right there, and you need to punch him, like, again, 4. You got to punch him 8 times, because I didn't pay you last time.
When do we get ours?
I don't know.
Did I need to fill that out already?
I think yours is a Tuesday.
Yeah, because when I looked on Mrs. Fix's calendar, on Monday, it was a Tuesday, so.
Yeah.
I have to double check with her, because
Yeah.
I'm
We have
useless.
to pay
Yeah.
for it by the 2nd, which is this Friday.
You guys have to pay for yours? Oh,
Yeah,
how rude. Okay, so that is a scalar. Yeah? Okay, are you ready? Now we're going to be multiplying matrices, and that's what the rest of this is. And multiplying matrices, I think is kind of fun. Sometimes people are like, what the heck? I don't like that. Okay, but I think it's kind of fun. So here's multiplying. This is the hardest part. Okay, and it gets to be a little crazy. So here's the deal. They say they're just getting us set up and ready to go. They haven't showed us how to multiply yet, but here's how you multiply. Okay, so let's say A is a 3 by 2 matrix. So matrix A right here is a 3 by 2. What's up? Thank you.
Thank you.
Thank you. A is a 3 by 2 matrix. Okay? Whatever. He's got 3 rows. 1, 3 by 2. So he would be like this. This is what he would look like, right? A 3 by 2. Okay? B is a 2 by 4. Okay, so he's 1, 2, 3, 4, 1, 2, 3, 4. That's what B looks like. He is a 2 by 4. Okay? Got it? That's what he looks like. A looks like that, B looks like this. Okay? Now, the rule here is not the same as adding and subtracting. Adding and subtracting, they have to be exactly the same size. If you are multiplying, like let's say I want to take A times B, here is the rule. If A is a 3 by 2 and B is a 2 by 4, do their middle numbers match up? Yes. Now, their middle numbers match up, and I'm going to cross those middle numbers out. The size that A and B will be is a 3 by 4. Do you see that? A times B will end up being a 3 by 4. The middle two guys cross out. Okay? If those middle two guys do not match, then you cannot do it. For example, let's say instead of taking A times B, I was taking B times A. B is a 2 by 4, A is a 3 by 2. Can I multiply those guys together? No, because 4 and 3 are not the same number. So I can take A times B, but I cannot flip them around and take B times A. Does that make sense? Okay? Those middle two dimensions have to be the same, and after you cross them out, what's left over is what your result will be. Okay? Got it? Okay. All right, so can the product AB be calculated? Yes. If AB can be calculated, what will its dimensions be? He will be a 3 by 4. Can B times A be calculated? No, because the middle two dimensions are not the same. If BA can be calculated, what is his dimensions? None. He will not have one because he does not work. Do you see why?
So you just put the 2,
What?
you put the 2's at the end again? For BA?
BA will not have dimensions because he can't, his middles don't match.
Yeah, but you just turn the 2's back in.
No, he won't have dimensions. He'll just be a none.
I know, but for BA, did you just throw the 2's back in for the example? To show that it doesn't work.
No. I
It's
don't
the
know.
same.
I'm
it's
confused.
the same numbers as A, B.
But it's reversed.
They're like different places.
Yeah, so like B is a 2 by 4, A is a 3 by 2. And in order for them to be able to multiply, these two have to be the same number. So they can't even be multiplied, so we don't even worry about what the dimensions of B times A is.
So you, like, just flipped A.
Yes, yeah, you flipped A and B. Yeah, is that what you're asking? Okay, sorry, I didn't catch that. Yep, you just switch the dimensions up, but that will not work. Okay, so now here's how we multiply. Are you ready? We're gonna do our first full-fledged multiplying. A is a 2 by 2. B is a what? 2 by 4. Can I take A times B? Yes, because 2 and 2 match up. They cancel out. Okay, what will be left? It will be a 2 by 4. Okay, so I'm going to do this. I'm going to write out a big old fat matrix, and I'm going to make him a 2 by 4. 1, 2, 3, 4. 1, 2, 3, 4. That is a 2 by 4. Got it? Okay. All right, are we ready to multiply? This is wild. This is wild. Ready? Okay. This is row 1. I'm gonna label this. This is row 1. This is row 2. Got it? This is column 1. This is column 2. This is column 3. This is column 4. You see how that works? Okay. All right. This is like a puzzle. Okay, we're gonna multiply A and B together, and the first thing that we're gonna do is we're gonna take this guy, which is row 1 of A, and I'm going to take him times column 1 of B. What? I'm going to take row 1 times column 1. Okay, so here's the deal. I take cell for cell. I take 1 times 1, which is 1. And I add that to, what's negative 3 times 3? Negative 9. So in this cell, I'm going to put my final answer down here. In that final cell goes negative 8. You see that? Woo! Okay. All right, the next one. I'm going to take, okay, I'm going to take row 1 times column 2. Okay, and you know where that's going to go? Where's that going to go? That's going to go row 1, column 2 right here. Okay, do you see that? All right, so I take 1 times 0, which is 0, and I add that to negative 3 times 1, which is negative 3. So final answer in that cell goes negative 3. Okay, you see how that works? Okay, now I'm going to go to the next one. I'm going to take row 1 times column 3. Okay, so I'm going to take 1 times negative 1, which is negative 1. I'm going to take negative 3 times 4, which is negative 12. So in that cell goes negative 13. Yeah? Okay. Now let's suppose you get lost and you're like, oh crap, I forgot what I'm doing. You're taking row 1 here, right? Row 1 times column 4. That one goes in the row 1, column 4 cell right here. You see that? You see how it matches up? Okay. All right, so I've got 1 times 2, which is 2. I've got negative 1 times, or excuse me, negative 3 times negative 1, which is positive 3. So in that cell should go 5. You got it. Okay, now we're going to start with the bottom, right? So now I'm doing row 2s. I'm doing all the row 2s. So 7, 2 times 1, 3. 7 times 1 is 7. 2 times 3 is 6. So in that cell should go 13, right? Yep. It's kind of confusing because you're multiplying, but then you have to add those together, right? Okay. All right, 7, 2 times 0, 1. 7 times 0 is 0. 2 times 1 is 2. So in that cell should go 2. All right, are we getting the idea? Okay, 7, 2 times negative 1, 4. 7 times negative 1 is negative 7. 2 times 4 is 8. So in that cell should go 1. All right. 7, 2 times 2, 1. 7 times 2 is 14. 2 times negative 1 is negative 2. So that is 12. This is your final answer.
Maybe do the next one.
Ooh. The next one, if we switch them, right? If we do B first, B is a 2 by 4, right? And A is a 2 by 2. And the rule says that the middle dimensions have to match. And they do not. So we cannot do B times A. It kind of seems silly because you're like A times B, like in normal multiplication, right? 2 times 3 would be the same as 3 times 2. I can switch them around. But matrices, it does not work that way. You cannot just flip them around because a matrix is a whole set, okay? So that's something called the commutative property. I think that's down here where it says non-commutativity. So AB is not always the same as B times A. Okay, all right, there we go. All right, multiplying square matrices in different orders. All right, find each product. Okay, A is a 2 by 2. B is a 2 by 2. And my middle dimensions match, and if I cross them off, I will end up with a 2 by 2. Okay, so I'm going to map them out. Boop, 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 boop. 2 by 2, and then I'm going to do my final answer right here. Okay? All right. Ready? 1, 3 times negative 2, 0. Row times column, right? So 1 times negative 2 is negative 2. 3 times 0 is 0. So negative 2 should go there. Okay, next. Oop. Okay, I take 1, 3 times 7, 2. 1 times 7 is 7. Where does that go?
To the right.
On the top right box. Yep, so 7 plus 3 times 2 is 6. So in that cell should go 13. Yeah? All right, now I'm on my bottom row. Negative 2, 5 and negative 2, 0. Negative 2 times negative 2 is positive 4. And 5 times 0 is 0. So in that cell should go 4. Okay? And next, negative 2, 5 and 7, 2. Negative 2 times 7 is negative 14. 5 times 2 is 10. So that is negative 4. And that's my final answer. Now, this time, can we do BA? Yeah, because it's 2 by 2 and a 2 by 2, okay? Now, here's the deal. Because I don't want to get confused, I'm going to rewrite them. Negative 2, 7, 0, 2. I'm going to do it like this. Because I can't, like my brain doesn't work backwards. So I'm going to write them as B times A. That way I make sure I'm doing all of the things right. Okay, because I want row times column, right? So row times column. Okay, negative 2 times 1 is negative 2. 7 times negative 2 is negative 14. So in that first top cell should be, what, negative 16? Yeah? Okay, now I'm doing that one, that row times the second column. So negative 2 times 3 is negative 6. 7 times 5 is 35. Ooh, negative 6 and 35 is 29. Yeah? Okay. All right, there's that. So I'm done with him, and I'm done with him. Now I got to go 0, 2 times 1, negative 2. 0 times 1 is 0. 2 times negative 2 is negative 4. So negative 4 goes in that cell. Okay, and then the last one, I always like when I'm multiplying by zeros. Zeros makes it nice, right? 0 times 3 is 0, and 5 times 2 is 10, so 10 goes in that cell. Yeah? Okay, so notice that when we do B times A and A times B, if they are able to be both be done, they're still not the same as each other, right? Like those are not equal. Okay, got it? Okay. Boop, 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 boop. All right, here we go. This is solely why we do this. Like why we do the matrix thing, okay? So here we go. Contractor builds 3 kinds of houses. Do you see the 3 kinds of houses? Okay, models A, B, and C. They made a matrix and they did models A, B, and C, okay? With a choice of 2 styles, a colonial or a ranch style house. So model ABC in a colonial or a ranch, okay? Matrix P shows the number of each kind of house the contractor is planning to build for a new 100 home subdivision. So he's building 100 homes. He's not building any Model A colonial, right? He's building 30 of the Model A ranch styles, right? He's building 10 of the Model B colonial, 20 of the Model B ranch styles to build 100 houses total. Does that make sense? Like all the way through, okay? So we've got those as our options. All right, so here we go, 100 houses. Those are my options, okay? Now we're gonna talk about how much everything costs. So we've got the amounts of each of the main materials used depend on the style of the house, okay? So in a colonial house, concrete only costs $10 or whatever. In a ranch style house, there's a lot more concrete, right? Lumber for a colonial is more than a ranch style. So it's kind of like concrete and lumber are kind of like flip-flopped, okay? There's no brick in a colonial, but there's 20 brick in ranch, and then shingles are the same for each one, right? So we've got that guy going on. So that's our price, or our units, I should say, not necessarily our price. These are the units of concrete, units of lumber, units of brick, units of shingles, right? And then we've got to go through and we've got the price for concrete. So concrete is $20 a unit, lumber is $18 a unit, brick is $60 a unit, shingles are $25 a unit, okay? So I've got all of these things going on, and notice that in this guy's columns are the same as this guy's rows, right? But then when we go from here to here, this guy's columns are the same as this guy's rows. Does that make sense? Okay, so that's why, like, when we multiply them together, the rows and columns end up, like, multiplying by each other. Yeah? Okay, all right, so, blah, 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 cost in dollars. Okay, what is the total cost of material for all houses of each model? Okay, how much of each of the 4 kinds of materials must be ordered? What is the total cost of materials? All right, so here's what we're going to do. We're going to, first and foremost, we're going to take P times Q, okay? Because this gives me my styles of houses, and I want to take those styles of houses and figure out how many units of each one we need, right? Okay, so I'm going to take P times Q. I'm just going to do that down over here. Okay, and I'm going to rewrite P and Q. Can I do that? 0, 30, 10, 20, 20, 20. What time do we get out of here?
In a minute.
Oh, gosh, we might need to stop. Okay, Q. I'm just going to rewrite these guys and we'll continue this tomorrow. 2, 1, 0, 20, 2, 2. Okay, oh, first and foremost, can we multiply these together even?
Yes.
P is a 3 by 2. Q is a 2 by 4. So we will end up with a 3 by 4. That's huge. Okay, we'll stop there and we will finish that
Figure out the cost.
tomorrow. What?
How do we figure out the cost if it's a 2 by 1 and nothing else is a...
So after we get this 3 by 4 matrix, right, then we're going to multiply that guy by this 4 by 1, and then that's going to give me my cost. Does that make sense? So that guy will end up being a 3 by 1, and that 3 by 1 will be my model A, model B, model C, and then the cost. Does that make sense? So it will tell me the cost for each ABC. We'll do that tomorrow. Okay, goodbye, people.